This video, I'm just going to talk a little bit about the properties of logarithms. So what I'm not going to do in this video is I'm not going to prove each one of these properties. The proofs are, relatively simple, but I think it probably is best for students for me just to discuss them a little bit. So when we first introduced logarithms, we talked about them as exponents. A logarithm is simply an exponent. And you could go back to the definition of a logarithm, okay, or rewriting it from exponential form to logarithmic form, right? So a to the power of y is equal to b. We could rewrite that as log base a of b is equal to y. So, y is equal to log base a of b, and we already know that y is the exponent. Okay, so hence the logarithm is equal to an exponent. So here we have the product property. It's our first property that we're looking at. And if we're taking a log, notice all the logs are the same base. Okay, in this case, they're all base a, so they're all the same base. That's important. So we're taking the log of u times v. That's equal to the log of u plus the log of v. Now, why is that true? Well, if you think of this, each one of these logs as being an exponent, right? This is an exponent, and this is an exponent, and this is an exponent. We could look at our properties of exponents and just relate them to this property. So we had a property of exponents where if we were multiplying, I'm just going to use different variables here. If we're multiplying like bases, right? Notice they both have a base x. If we're multiplying like bases, then we can rewrite those powers as a plus b. And you can see when we're multiplying like bases, we end up adding the exponents. Now, relate that to this. When you're multiplying like bases, you end up adding the exponents. Okay, so it's directly related. The properties of exponents are directly related to the properties of logs. Let's look at the next property, quotient property. So here, again, all the bases are the same. We're dividing inside our log, and we're saying that's equal to the difference between the two logs. Why is that true? Well, let's take a look at a property of exponents. If we are dividing like bases, there's a property of exponents that tells us we could subtract those exponents, and it's equal to, or it's an equivalent expression. So how is that related? Again, if we are dividing, that is equal to the difference of the two exponents. Remember, log statements are just exponents. And finally, the power property. So here, this property says if we, I think I'm missing some notation here. This really should say log base a of a to the power of n is equal to n times log base a of u. I don't like the way any of this came out. This should also be a u here. Okay, essentially what this property is saying is if this power right here, if we take a log of a power, we just end up bringing this to the front. So this is now n times log base a of u. And we've seen this property already used when I proved the change of base formula in the previous video. This is a property that's commonly used. And if we were going to go back and do the proofs of each one of the product property and the quotient property, we would see the power property pop up in both of those proofs. Okay. Okay, so hopefully this video has helped you make a little bit of sense of these properties. Again, you're not going to need to know how to prove these properties, but just to become a little bit familiar with them.